how to actually divide by 0. So I made a video last night, and I just rewatched it, and I was like, oh my god. Because it doesn't work, right? Well, there's a paradox in number theory that I've been sort of studying off and on for the last year about repeating numbers. And so if you take 1 divided by 3 and divide that by 3, you get 0.1 repeating, right? You take 0.1 and then you add that up 8 times, 9 times, 10 times, you get 1.0. And so 0.1 repeating 9 times is equal to 1 for some reason. And it doesn't make any sense. And the reason is because we round up numbers. But what the paradox says is that for every third that we use, because thirds always come out of an equation, somewhere in an equation, it's like inevitable that you are going to have thirds. And for every third then, to every sixth, and then to 3/3, which we would call a whole, we would actually have 0.9 repeating. But based on our calculations, we have limited, like calculating RAM, right? Whatever. There's limited decimal places that we can calculate on our phones, calculators, right? So that means that technically, whatever the limit of your calculator is a tenth off from being technically 0. So you would have 0.00 all the way down until the calculator can limit an infinitely repeating number. And that ends in 1, and that is where we round up numbers from. So that number is technically 0. Since we add that on to 0.9 repeating, when you take 0.1 repeating, you add that up to 0.9. You can add it up 8 times to get to 8, but once you get to 9, it's not just a series of 9s. And that's a paradox in number theory. And so based on, there's like that correction bias there, that how we could correct every calculation that we have to be a little bit more exact if we don't use, or if we do use, thirds, if we use fractions. So fractions, you're always going to encounter a repeating number somewhere, and that's how you create I always liken it to vectoring in space, because you have infinites that can run larger and infinites that can run smaller in both directions. And so whatever your relativistic limits are, or quantum limits, right, that you're going to agree that this is as big or as small something gets. 0 then is technically 1/10 off of that. So it's, you divide by 10, and then you have 0. And however many times that goes into something is dividing by 0.